So I'm going to find the inverse of this quadratic, and this is the whole process. You can go through the previous 3 videos and do it slowly, but if you need the whole process all at once, here it is. So the first thing I'm going to go ahead and do is I am going to type in the quadratic that is there, so negative 2x squared minus 12x minus 13, and I'm going to locate the vertex, which is negative 3, 5. And once I have that vertex, I'm going to write it in vertex form. So f of x equals to negative 2 parentheses x, moving it to the left 3, so plus 3 squared plus 5. Now, if you want to check it just to verify, I like to do that so I don't make any mistakes too early. Negative 2 parentheses x plus 3 squared. Oops, squared plus 5. Okay, there it is. It's perfectly verified. Next step is I'm going to find the inverse. So I'm going to solve for x, find inverse. And so all I do is I take y and I plug it in, and then I solve for x. So let's do that. So I'm going to subtract 5. 1 minus 5 equals to negative 2 parentheses x plus 3 squared, and divide by negative 2. And I'm going to take the square root. Okay, that cancels, so I'm left with x plus 3 equals to the plus or minus square root of y minus 5 all over negative 2. Remember, plus or minus because square root's got 2 answers. And I'm going to subtract 3. That cancels, x comes out. We get negative 3 plus or minus the square root of y minus 5 all over negative 2. The only thing I need to do now is write it in proper inverse notation. So I'm going to write that up at the top. F inverse of x equals to negative 3 plus or minus the square root of x minus 5 all over negative 2. Now, since that is there, I'm going to verify to make sure that they are inverses. So I'm going to say, type that in, negative 3 plus square root of x minus 5 all over 2, okay, all over negative 2, I'm sorry. And then I'm going to put the other one to be the same. So negative 3 minus SQRT, x minus 5 all over negative 2. Now, one thing that I like to do is we're going to check to make sure it's the inverse because, well, and it's not exactly the inverse. We have 2 inverse functions for part of it. So I'm going to put y equals to x. Okay, and as you can tell, it looks like everything is a reflection from the blue one over to the green and the purple one. And then what I'm going to do is I'm going to go ahead and change some things. I'm going to put something up here. I'm going to call this f of x. Remember in the previous videos, I just go ahead and name the other ones. G of x equals and h of x equals. I just name them. I'm going to clear the draw just to get rid of some of the action that's on the screen right now. Okay. Now the one thing I'm going to do at this point is I'm going to verify that they're inverses by putting them into each other. So I'm going to take f of g of x, and it should line up perfect, and it does. It's on the y equals x, and then I'm going to do that with h of x. Okay, and look, it lines up again. Okay. Now the last thing we may do is really do this thing where we considered restricting the domain. So for example, if I turn off the green one, the restricting of the domain is the last thing we do is we say, okay, well, we know there's 2 parts to the inverse. There's the green one, and then there's the g of x, and then there's the h of x. So I have to restrict f of x to match one of those. So for example, I'd go to g of x, and I'd say, well, which part of the original f of x is going to needs to be restricted. So I go up to the top, I go to the vertex, and I pick it out, x equals to -3. And I go ahead and write that down, x equals to -3. Restrict the domain, so I'm going to go to the original one. I'm going to say, okay, bracket. If I want the green one to be the inverse, I'm going to say x is either greater than -3 or less than -3. So greater than or equal to -3. Okay. Bracket and check it out. Visually, you can tell automatically that they are inverses of each other. And watch, if I back it up, you can tell if I do the less than or equal to, they're not reflections of each other. So I switch it back, greater than or equal to, and that is the restricted domain for the green graph. Okay. If I need the restricted domain for h of x, I'm going to type in, I'm going to find the vertex again, which is still -3, and I'm just going to verify, do I need to change the inequality? So I say, is it less than or equal to? Hey, check that out. Okay. Then they're reflected, and this piece right here, that is the restriction that I have to put on the original equation to match up with one or the other of the inverses.